Let's use our factoring methods to look at these practice examples. So our first example here, we have 16x squared minus 100. So first of all, I have a binomial, something with two terms. So I can either pull out a greatest common factor to start, which is an option, or I could see if there's a difference of two squares. So I'm personally going to start and see if this is a difference of two squares because I already see it's a difference. There's already subtraction here. So that is a sign that maybe it's a difference of two square numbers. But I have to think about if there's something being squared to be each of these numbers. So can anything square to be 16? Yeah, 16 is 4 squared. And I want x squared, so it has to be 4x getting squared, because then I would get 4 squared is 16, x squared is x squared. Perfect. Can anything squared to be 100? Yeah, 10. So this can factor to be 4x plus 10 times 4x minus 10. Nice little difference of two square numbers there. Now, I'm going to personally jump to the other binomial that I see on here. I'm seeing a lot of trinomials, lots of 3 terms. Those would be similar methods. Either greatest common factor can be tried on anything if you want to, and then the reverse foiling for 3 terms. But I'm going to jump to this last one here because I see one other binomial. I'm just going to try to tackle them all at once. So I have another binomial with a difference. There's subtraction there. So I want to see, is it a difference of 2 squares? So I'm thinking, can anything square to be 6x cubed? Well, no. 6 is not a perfect square. 2 squared is 4, and then 3 squared is 9. There's not a nice whole number that can square to be 6. And then same thing actually with 24. 5 squared is 25, but nothing squared is 24. So I'm going to start with the greatest common factor on that one. I can't think of something that squares to be each, so I'll start with the greatest common factor, and I'm thinking, what's the biggest number that goes into 6 and 24? Well, 6 definitely goes into itself. Does 6 go into 24? Yeah, it does. 6 times 4 is 24. So I'm going to pull out a 6, the biggest number and the least power of x. So the biggest number is 6, and the least power of x is just a regular x that I see here with the 24. And now let's see what multiplies back. So we have 6x times x squared would give us 6x cubed. And then 6x times negative 4 would give me that negative 24x, right? We can check it. 6x times x squared is x cubed, 6x cubed. And then 6x times negative 4 is going to be that negative 24x. So that looks good so far. But now I'm seeing another binomial in here, x squared minus 4. So I want to double check, can I do difference of squares with that? There's no more greatest common factors. We already did that. So there's no big number, least power of x, but it is a difference of 2 square numbers. It's x getting squared and 2 getting squared. So I'm going to write this as 6x, and then I have x plus 2, x minus 2. Because if I notice, which you can do the side work, you definitely don't have to, but this is x getting squared and 2 getting squared. So it's going to be x plus 2, x minus 2. All right, we did the 2 binomials, 2 ones with 2 terms. And now we're going to move on to these trinomials here. So looking at letter B here, we have x squared plus 5x plus 6. There's no greatest common factor because the only number I could pull out is 1. And then the least power of x is, well, there is no x on 6. So there's no big number and least power of x to pull out of all 3. So I'm going to go right to reverse foiling. I want to multiply to be which one, the 5 or the 6? You always multiply to be the last term and add to be the middle term. So I want to multiply to be a positive 6. This is tricky because 2 positives multiply to be a positive and also 2 negatives multiply to be a positive. So which one is it going to be if I want to multiply to be a positive 6 but add up to be a positive 5? If I choose a negative times a negative, 2 negatives are going to add up to be negative. So it must be a positive times a positive to multiply to be a positive 6 and add up to be a positive 5. So thinking of factors of 6, we could use 6 and 1, but 6 plus 1 is 7, so that doesn't work. So other factors of 6 could be 2 and 3, and 2 plus 3 is 5, so that must be the one. X plus 2, x plus 3. Order doesn't matter. So you could write x plus 3 times x plus 2 if you'd like. But it adds up to be 5, 2 plus 3 is 5, and multiplies to be 6. 2 times 3 is 6. Now let's jump over next door to this one here because it also ends with a positive factor. We have a positive 20 at the end. And we could try to pull out a greatest common factor, but again, there isn't one. There's no big number to pull out. We can only pull out a 1, and then there's not an x to pull out, so factoring out a 1 wouldn't get us anywhere. So we're going to do some reverse FOILing. We're going to multiply to be 20 and add up to be -9. So to multiply to be 20, we either have a positive times a positive or a negative times a negative. But this time it's a little bit different. We want to add it to be a negative number instead of a positive number. So we must have 2 negative factors. 2 negative factors multiply to be positive, but add it to be negative. What are our factors going to be? -20 and -1 would add up to be -21. That doesn't work. We want to add it to be -9. If we try -2 and -10, that would multiply to be the positive 20, but -2 plus -10 would give us -12, so that doesn't work. We need -5 times -4 is positive 20, but -5 minus 4 gives us that -9 middle term that we need. So for these two that we just did, we ended with a positive factor. So it could either be 2 positives or 2 negatives multiplied. And that middle term told us if it's positive, the factors are both positive. If the middle term is negative, both factors must have been negative. So we're going to see a lot of patterns in math, and that's one of them. Nothing to memorize, but just something that you could observe. Might help you in the future. Now, these last two, I'm looking at letter C first. So we have x squared plus 4x minus 45. So we want to add up to be a multiply to be a negative number. We're going to multiply to be -45 and add up to be a positive 4. So I love it when we get to multiply to be a negative number because it's going to be a positive times a negative for sure. Can't be anything else to multiply to be a negative with these two factors. There's no greatest common factor, that's why I'm jumping into this reverse FOILing. I want factors that have a sum of 4. So the bigger number is going to be the positive one. So we can add it to be positive 4. And I want to think of factors of 45 that differ by 4. So definitely not 45 minus 1 because those differ by 44. So I want to think of other factors of 45. So maybe 15 times 3, but 15 minus 3 is 12. So those are two different. We needed something closer. Can you think of numbers? You should do x plus 9 times x minus 5. 9 minus 5 is 4. 9 times -5 is -45. So we got that one down. And we have one more over here that multiplies to be a negative. It is a trinomial, so I'm not even trying difference of squares. That wouldn't be a possibility. There's no greatest common factor here. But we want to multiply to be a -40 and add up to be -6. So it must be a positive times a negative to multiply to be that -40. And this time I'm going to choose the bigger factor to be the negative one to make sure that when I add them up, I get a -6 instead of a positive number. So factors of -40 that differ by 6. So not 40 minus 1 or anything like that. Those differ by 39. So we want numbers that are closer than that. We could do, what do you think? We need a -10 and a positive 4. 4 minus 10 gives us that -6 that we're looking for. 4 minus 10 is -6, and 4 times -10 is -40. So there's some factoring review.